let's take a look at how quickly we can find critical values using Minitab in order to construct our confidence intervals. In this demonstration, I'm going to show you how to find both z-critical and t-critical values. Now, as a reminder, critical values are the values that separate sample statistics that are probable from those that are improbable or unusual. As you are hopefully learning in your statistics class, there are times when you will use z-values and times when you will use t-values to separate these areas in your distribution. Now, I will show you when you have a distribution, you are going to have a distribution that looks like this. And you're going to have these critical values right here that separate this area right here of probable values from your area of improbable values right here. And here are your critical values, either z or t. So it depends on which type of distribution we're using. But we're not going to cover that, determining whether we're going to use Z or T in this demonstration. I do have other demonstrations posted that explain how to know which type to choose, and you can watch one of those. But for this one, I'm just going to show you how to calculate the specific critical values using Minitab. So let's take a look at how we can do that. Okay, let me erase that writing there. That shouldn't be there. And like magic, it's gone. Isn't that just the wonderful magic of video? So let's find the critical value of Z needed to construct a confidence interval at the given level of confidence. And I'm just going to run through these three quick examples for you. So we're going to find Z critical for a 90% confidence interval, a 95% confidence interval, and an 85% confidence interval. So we're going to go into Minitab, and we're going to go under the graph function, and we're going to go to that probability distribution plot of which I am so fond because it does so much for us. And we're going to go to view probability and click OK. Now, since we are doing z-critical, we are going to go under the normal distribution, and we're going to leave our mean as 0 and our standard deviation of 1. We're going to go to shaded area, and we're going to tell Minitab that we want both tails because we want to separate that probable from improbable in our tails. And what we need to do is leave probability checked. And here is where we just need to tell Minitab what we're doing. We need to tell Minitab what our probability, or essentially our confidence, is. So here is what we need to do. We need to tell Minitab what probability is in these tails right here, and we need to tell it the remaining probability. We do not need to do the division by 2. Minitab will do that for us. So if we're looking at the 90% confidence interval, we have 10% divvied up between those two tails. So we just need to tell Minitab that we have 0.10. We have 10% in our tails. So the way I found that was 100% minus 90%. So I'm going to enter in that 10% there, and I'm going to click OK. And look at that. Minitab just drew that up there, and it shaded in those improbable areas, and it split that 10% up into 5% into each tail, and it gave me that critical value of 1.645 for the 90% confidence interval. Now that 1.645 is a common z-critical value, which you most likely won't need to calculate over and over again. So, but I just wanted to show you that one so that you would see that it does give you what you're used to seeing. So let's run back in there and do the 95% confidence interval and see what it gives us. Now remember, we can just go back into here into our editor that we were already using. We don't need to go back under graph and probability distribution again. I'm going to go under shaded area, and the only thing here that I'm going to change is the confidence interval level, or the confidence level that I'm using. And here, instead of 10%, I have 5% that I need divvied up. But I don't need to do the division. Minitab's going to do that for me. And I'm just going to put 0.05. And if you want to just back that whole thing out, and you can put 0.05. And then click OK. And look at that. Minitab split it up into 0.025 in each tail, and there are your critical values of 1.96. So then let's go back in and let's do 85%. So again, here we are. We're going to leave it at 0 and 1. And what do you think our shaded area should be down here, our probability? We are going to subtract 100% minus 85%, which gives us 15%. So we just need to tell Minitab that it's going to divvy up 15% between the two tails. So it's going to be nice and do that math for us. So we just need to tell it 0.15 is what we have. And look at that. It gave us 0.075 in each tail and our critical value of 1.44. So Minitab is very nice like that and does all that hard work for us. So there is the method for finding z-critical using Minitab. It will also calculate our t-critical values. So let's take a look at how to do that. So finding t-critical requires a little bit more information. However, it is just as quick and easy. We do need to have our sample size when we find the t-critical value because we need to know our degrees of freedom. So we still go to the same place. Let's go up under Graph, Probability Distribution Plot, View Probability. And the only reason I didn't go back under Sample Editor up underneath there again was just to show you the steps one more time. Click OK. Now, under Distribution, we're going to change to T because we need to tell Minitab that it's working in the T distribution instead of the normal distribution. It's not looking at Z values anymore. It needs to look at T values. Minitab's pretty smart, but it can't read our minds. So now it wants to know your degrees of freedom. So if you recall, degrees of freedom are calculated by taking your sample size minus 1. So degrees of freedom equal n minus 1. And I don't know why my pen's not drawing very well there. So it's going to be 15 minus 1. So my degrees of freedom here on the first one are 14. So I'm going to enter in 14 here for my first one. And then I need to come over here and I essentially need to just do the same thing again. And I need to enter in the probability. And since it's a 95% confidence interval, I need to tell it 0.05 and click OK. And there are my t-critical, 2.145. So let's try it for 99% confidence with a sample size of 16. Now this time I'm just going to go back in here into my Edit Last Dialog because I like to do that. It's fewer clicks and I'm just lazy like that. And my degrees of freedom would be the sample size minus 1. So my degrees of freedom here is 15. Go to my shaded area and I need to enter in my probability. So it's 99%. So it's 100% minus 99%. So it's 0.01. And I click OK. And there it is. I have a t-critical of 2.947. So let's do one more. Let's finish this off. We have 98% with a sample size of 20. So our degrees of freedom here would be 19. Our shaded area, and we need to enter in the probability of 0.02 because 100% minus 98% is 2%, and that written as a decimal is 0.02. Click OK. And it has split up that 2% into the tails as 0.01. And there are my t-critical of 2.539. So Minitab really makes this so much faster than having to do it by hand, which I did show you how to do it by hand in another video. Just in case you don't happen to have Minitab handy, doing it manually is really not that difficult, but Minitab always makes it so much simpler and a lot more fun because I love technology. So I hope this really helps and helps make your homework a little bit simpler.